I welcome all of you to this course on refrigeration and air conditioning. In this lecture, we will see simple vapor compression refrigeration cycle. Our domestic refrigerator, air conditioner, water cooler, etc. are working on a cycle called simple vapor compression refrigeration cycle. Before talking about this simple vapor compression refrigeration cycle, I would like to explain about second law of thermodynamics, that is Cauchy statement. According to Cauchy statement, it is impossible to construct a machine which while working in a cycle will pump heat from a lower temperature to higher temperature without the help of an external agency. Heat will flow from higher temperature to lower temperature only because at higher temperature heat is having higher heat intensity. So definitely heat will flow from high temperature to lower temperature only. But if you want heat to flow from lower temperature to higher temperature, according to second law of thermodynamics, it is possible, but it is possible only if and only if you provide an external work input. Now this is our domestic refrigerator. Domestic refrigerator, we have the freezer at the top of the refrigerator. This is the perspective view. Now we have the at the top of the refrigerator we have the freezer, and over which you can see a coil, that is called evaporator coil. Behind the refrigerator you can see another coil, that is called condenser, that is outside the refrigerator. At bottom you have a compressor, that is inside a black color shell. It is actually a hermetically sealed compressor, and also you can see a capillary tube inside. Now this view will give you a clear idea about different components. Front side, right side you have the door, and at the top you can see the evaporator coil, and then outside you can see the condenser coil, and at the bottom you can see the compressor. Also you can see the expansion valve. Now this is the sectional view of our window AC. Okay, window AC, you have two coils. One coil is exposed to room to be cooled, whereas other coil is exposed to the outside air. You have fans or blowers to blow air, and also you can see a compressor at the bottom, and also you have a expansion device. All these devices are working on the same principle, that is called simple vapor compression refrigeration cycle. Now this is simple vapor compression refrigeration cycle. You have the components like a compressor, a condenser, expansion valve, and an evaporator. Now red color thing, that is the condenser side, it is called high pressure side, and blue color side, it is evaporator side, that is the low pressure side. Function of the compressor is to increase the pressure of a gas, whereas condenser is to condense a gas. Now expansion valve is used to expand a liquid so that its pressure and temperature can be reduced, and evaporator is used for vaporization, that is when a liquid flows through the evaporator coil, the liquid vaporizes. Now next is the refrigerant. A refrigerant is a fluid which is used in this cycle. Now the function of the refrigerant is to absorb the heat from the space to be cooled and reject that heat to outside atmosphere. Now the commonly used refrigerants are R12, R22, R134A and R410A. Now see this, you can see the direction of the flow of the refrigerant. In this cycle a fluid called refrigerant is used, and you can see with that using that arrow the direction of flow of the refrigerant is given. Now compressor, from compressor to the condenser, then to the expansion valve and evaporator. Now refrigerant, we are choosing the refrigerant in such a way that at room temperature the refrigerant should be in a vapor form, so that when we switch on the system, everywhere the refrigerant is in the vapor form. Now compressor, what happens is, now you will see various components. First one is a compressor, then condenser, expansion device, and evaporator. Now compressor, what happens is, when the low pressure, low temperature vapor refrigerant passes through the compressor, it is compressed to high pressure and high temperature vapor. Now why it is done is, when the compressor is when the pressure is increased, the temperature also increases, and when once you increase the pressure, the gas can be simply very easily condensed. Now you are increasing the pressure of the refrigerant so that it can be condensed at higher temperature or room temperature. Next you have a condenser. When high pressure, high temperature vapor refrigerant passes through the condenser coil, it rejects its latent heat to outside cooling media and gets condensed. That is, you can see vapor minus HFG gives liquid. So vapor refrigerant at higher pressure and higher temperature rejects its latent heat to outside atmosphere and will be condensed to a liquid. Here HFG is the latent heat of the refrigerant. Now you have a third device called expansion device. So already the refrigerant is now in the liquid form because it is condensed in the condenser coil. Now when this condenser refrigerant passes through the expansion device, this this liquid refrigerant expands. Okay, when a liquid expands, it's partially it vaporizes, and due to this, what happens there is when a liquid passes through an expansion device, its pressure reduces, and partially its pressure reduces. So due to this pressure reduction, part of the liquid refrigerant vaporizes. Now this the latent heat for the vaporization of this part of the liquid is taken from the remaining liquid. So remaining liquid temperature reduces drastically, whereas the part of the refrigerant vaporizes. So what happens in expansion device is when a liquid passes through the expansion valve, a part of that liquid vaporizes because of the pressure reduction. Now when a part of the refrigerant or fluid vaporizes, it needs some latent heat. So that latent heat is taken from the remaining liquid, and the remaining liquid vaporizes and remaining liquid temperature reduces, whereas the part of the refrigerant vaporizes. So in that way temperature reduces. Now next, when already after expansion valve, expansion device, temperature is reduced. Now that low temperature liquid, whose pressure is also low, passes through the evaporator coil. Now outside the space to be cooled, the temperature is slightly more than the refrigerant. So that heat will be sucked from that space to the refrigerant. So that refrigerant absorbs its latent heat from the space to be cooled, and space to be cooled the temperature of the space to be cooled reduces and it starts cooling, whereas the liquid refrigerant which passes through the evaporator coil gets vaporized. So that means you can see liquid plus HFG gives vapor. That is where HFG is the latent heat of vaporization. Liquid absorbs its latent heat from the space to be cooled and liquid vaporizes, whereas the space to be cooled starts cooling. So this next, now after evaporator, you can see again the refrigerant is in the vapor form. This vapor refrigerant is sucked by the compressor and it is compressed to higher pressure and higher temperature so that it can be condensed now. So this same cycle continues. Now this is the vapor compression refrigerant cycle once more. Now you can see the compressor 1-2 is the compression. The compressors that is a saturated vapor is sucked by the compressor. It increases its pressure and temperature. So it is now after compression it is in a superheated region. Now this superheated vapor refrigerant passes through the condenser coil. Now why it is compressed? The reason is that once you increase the pressure, you can condense the refrigerant at room temperature itself. Okay. Now since pressure is increased, temperature also increases. So due to that, the temperature inside the condenser will be more than that that of the temperature outside. So that latent heat will be rejected to outside atmosphere, whereas the liquid condenses this to point 3. Now at the point 3 you have saturated liquid, then this liquid after condensation, okay, this liquid now it is expanded through the expansion valve, where the expansion occurs through a expansion valve. So it is not an isentropic expansion, but it is an isenthalpic expansion. That means the enthalpy remains a constant, whereas entropy slightly increases, because it is not an expansion, it is not a turbine, it is an expansion valve. So enthalpy remains a constant, entropy increases. And now, but the liquid, the temperature also decreases because of the expansion. Now after the expansion valve, that is the point 4. The liquid is in the liquid is at lower temperature and very low temperature, lower pressure and very low temperature. This low temperature, low pressure liquid refrigerant, when it passes through the evaporator coil, it absorbs the heat from the space to be cooled and gets vaporized to stage 1, and this is sucked by the compressor for next cycle. Now we will see the TS diagram of that. 1-2 is the compression, whereas it is a compression is a isentropic process. You can see in TS diagram, the curve 1-2 is a straight line perpendicular to the entropy axis. So it's a straight line perpendicular, that is a vertical line. So that is 1-2, that is a compression. Then you have 2-3. 2-3 is a condensation, that is high temperature, high pressure vapor refrigerant rejects its latent heat to outside atmosphere, so it is to be condensed. But the point 2 is in the superheated region. So you can see first there is a desuperheating, then only condensation occurs. So in that curve you can see 2-3 first part is that inclined line is the desuperheating, and then a straight line parallel to the entropy axis or constant temperature, that is the condensation. Now after the point 3, after condensation, it is the expansion. So when the liquid refrigerant passes through the expansion valve, it expands, and where the temperature reduces and entropy slightly increases, but enthalpy remains a constant. Now that is the point 3. So that is the point 4. At the point 4, the temperature will be drastically reduced. Now at the point this after expansion, the lower temperature, lower pressure liquid passes through the evaporator coil, and then it absorbs the heat from the space to be cooled and gets vaporized to stage 1, that is 1 is saturated condition. So you can see 4-1 is the evaporation process of the refrigerant. Now the same cycle, if you represent in a pH diagram, you can see 1-2 is a compression. So due to 1-2, the pressure increases as well as the temperature increases. So 1-2 is an inclined line as shown in diagram. Okay, so 1-2 is it's an isentropic process, but enthalpy remains, enthalpy increases. So next you have 2-3. 2-3 is a condensation. 2-3 is a constant pressure process. There is no pressure increase during the process 2-3. So you can see 2-3 is a constant pressure process in a pH diagram. Then we have 3-4. 3-4 is an expansion, and expansion is actually expansion is a constant enthalpy process. So it's a, you can see in pH diagram, it's a vertical line. It's a constant enthalpy process because expansion occurs, in this case expansion occurs in an expansion valve, not in a turbine. So in that case, when it's a Joule-Thomson expansion only, so it's just a constant enthalpy process. Now after that is after expansion, the temperature of the liquid is low. Now then that liquid passes through the evaporator coil, where it absorbs the latent heat from the space to be cooled and gets vaporized to condition 1. That is 4-1 is the vaporization of the liquid refrigerant. This occurs when it absorbs its latent heat from the space to be cooled. So there you can see the space to be cooled. During the cycle, what happens is when refrigerant circulates through the entire cycle, it absorbs the its latent heat from the space to be cooled and rejects that heat to outside atmosphere. That is, when it passes through the evaporator coil, it absorbs its latent heat, and when it passes through the condenser coil, it rejects that heat to outside atmosphere. Now this is the, in this diagram you can see this is also a pH diagram, but the condition is different suction condition. So if suction is saturated vapor, you can see 1-2 will be the pressure, pH diagram. Okay, but whereas if suction itself is superheated, you can see 1-2- will be the compression. Okay, so when suction is when suction is saturated, so, saturated condition 1 2 will be the 1 2 will be the compression process, whereas if suction itself is superheated, suction condition is superheated slightly, maybe 5 or 10 degrees superheated, then you can see it will follow a path 1 dash 2 dash. Now after condensation, you can see condensation is a constant pressure process. Then after condensation, if it is the saturated liquid, then the curve will be 4 3 4. It's a straight line, but it will start from the point saturation point, that is 3, and then it will be 3 4 will be the expansion process. Whereas if after condensation itself, if there is a subcooling, maybe 3 or 4 degrees or 5 degrees subcooling, then it will follow a path 3 dash 4 dash. So from this I hope you got some basic idea about the vapor compression refrigerant cycle and the TS and pH diagram. Thank you very much for listening to this lecture. Thank you very much.